Welcome to section 5.6. Our objective is I can apply inequalities in two triangles. So we're going to be talking about the hinge theorem today. Super easy. So if you have two triangles and you have two sides are congruent, let's say this is 2 and this is also 2, this is 3 and this is also 3. The bigger the angle then between those, the bigger the side. So if angle A here is bigger than angle D, then this side is going to be bigger than this side. Okay, so the hinge theorem tells me that if I have these congruent, these two sides, then the included angle, this angle right here, will tell me if the side is bigger. Same thing over here. So if you have, let's say, 2 and 3 again, so this two sides are congruent, requirement, okay? And we have that this is like 52, and this is 10. Of this side and this side, which side is bigger? Well, LK would be bigger. Okay. Same thing the other way. If you had like 5 and 4, you could say the same thing for the angle. So if this side is bigger than this side, then this angle is bigger than this angle. Okay. So you can go angle to side, side to angle. So the hinge theorem, sorry, very roundabout way to talk about it. But the hinge theorem, if two sides of one triangle are congruent to the two sides of the other triangle, so 2 and 3 here, okay, and the included angles are not congruent, okay, one's bigger than the other, then the longer the third side is across from the longer included angle. So if this angle is bigger than this angle, then this side is going to be bigger than this side. Okay, that's the hinge theorem. The converse is the other way around. So if we have the two congruent sides of two different triangles, and this side is bigger than this side, then this angle is bigger than this angle. Okay, and I'll show you what that looks like. So on this one, we're going to compare. You might see this word on a test. Compare BAC, this angle, and DAC, this angle. Okay, we're going to compare those. So first of all, we need those two congruent sides. We have 4 and 4, good, okay. And then we need one more. So see how we're going to sandwich these in, kind of make a little V shape. So this is my other congruent side, which is congruent to itself by the reflexive property. Okay, so I have my two congruent sides and the angle between. Do you guys see that? It makes a V. Okay, that's the requirement for hinge theorem. Now we're going to compare these. So looking across from it, I have a 7 and I have a 6. So which angle is going to be bigger? Is it going to be the one with the 7 across from it or the one with the 6 across from it? The one with the 7 across from it. So I can say the angle, and let's see which angle this is. BAC is bigger than angle DAC. Okay, that's how we're going to compare those, and that's it. That's my answer. So you just compared them, and that's how you do it. You don't need to write all that, and you don't need to write all this. You're just writing straight up that inequality. This angle is bigger than that angle. Okay, let's look at this one. We're going to compare EF and FG. Okay, so let's write that off to the side. So you got EF, FG. We're going to compare it. We're going to write an inequality right here. So let's look at it. Okay, we have congruent sides here. We need one more. Looks like this is congruent to itself. Okay, we have this angle. Ooh, how do we find this angle? Well, this is actually a linear pair. So you're going to do 180 minus 82. And what do you get? You should get 98. 98 degrees. That's actually a band from back in the day. If you guys don't know about it, they're pretty good. Anyway, so 82 and 98. So now we're going to compare these two sides, which happen to be the sides opposite of these angles. So of these, I got 82, 98. Which side is going to be bigger? Well, the one across from the 98, which is FG. So this one is bigger. So EF is smaller than FG. Okay, and what we used there was the converse of the hinge. Actually, sorry, that was the original hinge theorem, wasn't it? That is the hinge theorem. The other one is the converse. So the converse is if you have the sides and you're finding the angles. The original hinge theorem is if you have the angles and you're finding the sides. It's alphabetical. So original is A to S. The other one is S to A, sides to angles. Okay, looking at this one, we're going to find the possible range of values for this. Okay, so looking at this, which angle is going to be bigger? Is it going to be the one across from the 19 or the one across from the 18? The one across from the 19. So the way I'll write this is I'll write 5k minus 12. This is the one angle. It's going to be smaller than the 38 degrees. Okay, I'm not going to touch the 18 or the 19. That just kind of tells me which one was bigger. So I have the two angles. And now I can actually solve this and figure out what it would be. Let's see what k could be. So we have 50. So k is smaller than 10. K is going to be smaller than 10. Excellent. Okay. Now, thinking about this, we have to have another range, don't we? Because it says a range of values, which means there's several. So k is less than 10 is one of them. Now, thinking logically about this, we have an angle. What can an angle not equal? Well, you can't have a negative angle, and you most certainly can't have a zero angle. So this angle right here, this whole thing, needs to be bigger than 0. It's not going to be equal to 0 because that would not be an angle. It needs to be bigger than 0 in order to actually be an angle. Now if I solve this and k turns out to be a negative number or 0, that's okay. That could happen. We're trying to figure out if the whole thing is bigger than 0. So let's solve for k now. And we get k is greater than, 12 over 5, which I think they did on this step down here. 2.4, same thing. Okay, and so then you have your range of value. You can write it this way, or you could write it separate. That's okay too. But there you go. So recap, when you find the range of values for k, you're going to do which one's bigger. So this one or this one, write your inequality. And then your other range is always going to be this is bigger than 0. Okay, the one with your variable is going to be bigger than 0. This is how it's always going to be. Okay, let's do another one. So compare the sides this time. So let's see, we're just comparing the sides. Let's just compare the sides, okay. Compare the sides and we're finding the measure of angle of these. Okay, so EGH, this guy, and EGF, this guy. Okay, congruent, congruent, there's my other congruent. Okay, you need to have the two congruent sides, don't forget that. Now let's compare it. So is the angle with the 10 across from it bigger or the one with the 9 across from it? The one with the 10 across from it. So I'm going to write it in the same order here. So you got EGH, EGF, and which one was that was bigger? EGF, bigger. There we go. Just like that. Okay, compare BC and AB. Whoa. Or we could go off the page. BC and AB. Okay, so looking at this, these are sides. We have congruent, congruent, congruent. Awesome. So 64 and 65. Which one's bigger? Well, this one. So BC is bigger. Okay, so anytime you see compare, that's all you're doing. You're writing an inequality. Super, super easy. Don't need to figure anything out there. The only thing you would need to figure out is the range. Okay, so let's look at this one. You get a little bit of a word problem, but it's not actually that big of a word problem. So John and Luke leave school at the same time. John rides his bike, weird accent. Okay, bike 3 blocks west. So we're going west 3 blocks, okay. And then 4 blocks north. Cool. Okay. Luke rides his bike 4 blocks east and then 3 blocks at north 10 degrees east. Which doesn't make sense. But that's south. That doesn't make sense. That should be south. Because that's south. That's weird. I have no idea. That's weird. Okay. Who is further from school? So you matchy, 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 matchy. And we're trying to figure out who is further from school. So we're looking at these angles. And this is weird. Yeah, we're just figuring out the angles, I guess. This is the weirdest word problem on the planet. Okay. Anyway, which one is bigger? So, yeah, that's really... Oh! I got it. We're trying to figure out this. Which side is bigger? Yes. Good job if you caught that before me. I'm a little out of it today. Okay, so south, 10 degrees east. So if we go south, here's your compass. If you go south and then you go 10 degrees east, so south is 90 degrees. Do you see that? Straight down. And then you go 10 degrees east. How big is that angle? 100. Okay. This one is going west and then straight north. So you go west and then straight north would make a 90-degree angle. There we go. Okay. So recap of that. Just think of your compass. If you go to an intersection and you just turn right, that was a 90-degree turn that you did. Okay, if you're at one of those weird intersections that kind of goes a little wonky, it's going to be a little bit more than 90 degrees. Okay, so which side is bigger? So here's your two triangles. I labeled it all for you. Which side is bigger? This one. So Luke would be further away from John than John. Luke is further from the school than John. Okay, now we're into proofs. Now don't be scared by these proofs. See how short they are? 3 steps. Okay, so given AB is congruent to CD, ABD is bigger, it's very big, already big, than CDB, this guy. This is small. Okay, so we're trying to prove that AB is bigger than CB. These. Oh, this should be AD. Wow, they are typo magoo up in here. Okay, there we go. AD. Okay, now you might be tempted to just jump straight into it and go from given to, okay, well, this one's bigger than that one. But don't forget, for the hinge theorem, you need the 2 congruent sides. So you already have this pair of congruent sides in your given, but you also need this one using the reflexive property. Okay, then you can say, well, this one's bigger than this one by the hinge theorem. Okay, so in order to use the hinge theorem in these very short proofs, you need to say that the 2 sides are congruent. Okay, so you got side 1, and then you got the matching side 2. Okay, let's look at this one. Okay, we're going to label everything. Okay, and I'm just going to talk it out, and then I'll show you what the proof looks like. So we'll start with the given. Yeah, C is the midpoint of BD. Cool. Okay. Angle 1 is equal to angle 2. And angle 3 is bigger than angle 4 that's smaller. Okay. And we're trying to prove that AB is bigger than ED. Okay. Don't forget we need those 2 congruent sides. So easy one. C is the midpoint. Okay. This is congruent to this one by the definition of midpoint. Okay, now we need to show that the other sides are congruent. So this side and this side, how can we show that those 2 sides are congruent? Do you see them? It's this one and this one. Okay, do you see this triangle right here? What type of triangle is that? Well, I see the 2 base angles here are congruent. And congruent base angles mean it's an isosceles triangle. So if it's an isosceles triangle, the 2 sides are congruent. Boom. Got my 2 congruent sides. Now, since this side or this angle is bigger than this angle, I can now conclude that that side is bigger than that side. And this is what the proof looks like. Look, it's everything I talked about. Okay, the converse of the isosceles triangle theorem. Ta-da! Good job, guys. So feel free to rewatch this video if you need to. I know proofs can be hard, but don't overthink it. They're just short and sweet, okay? You need the 2 congruent sides, and then you can probably jump straight to the hinge theorem.